Okay, students, so we're here and we're going to focus on rotations. Just a little quick review if you're having some trouble remembering. So we're going to rotate this figure 90 degrees counterclockwise about the origin. So first off, 90 or counterclockwise is this way. It's the way a clock does not turn. So just think of the clock, that's clockwise, counterclockwise, the opposite way. This point right here, that's the origin. Sometimes it's called 0, 0. And we're just going 90 degrees. All right. So since we're in quadrant 1, that means that we'll end up somewhere in quadrant 2. Okay. Now for fun, let's just focus on B. B is at 4, 5. So if I do a 90 degree counterclockwise rotation around the origin, let me see if I can do it like this. All right, I might get some stuff I don't necessarily need, but let me copy, paste image, and then, let me undo that. Paste image, struggling a little bit. Paste image, third time's a charm. There we go. So then let me bring it down just here a little bit. Okay, so let's focus on B and let's focus on the origin, all right? The origin is still in the center, all right? So that's what's important. And notice how now, after I did this, notice how it's 5 left, 4 up. Well, that just means that my coordinates of B, which you can actually see, B prime, is going to be -5, 4. All right, so I know on the previous video, I physically rotated my paper, but I realized in Notability, you can copy and paste it, all right, and then rotate the image that way. All right, so that's the coordinates of B prime, -5, 4. You can also use the rules, all right, and then you can do the same for points S and L, all right. Now here we got another rotation problem. All right, find the center. All right, so what's this? This is basically 3 points. The center of rotation for this class will always be 0, 0 or the origin. Technically, well, not technically, you can rotate around any point you want, but we'll just keep it simple and do the origin. It's really not that bad to do it around any point, just a little bit more work. So that would be that right there. And then we're going from X to X prime. All right. So one thing to say is, well, notice how this is in quadrant 4. We're starting in quadrant 4. We're ending up in quadrant 2. We're also going counterclockwise. So since I'm moving 2 quadrants, that means it's going to be a 180 degree rotation. It's on the exact opposite side. All right. So just look at the quadrants. Look at where you start. Look at where you're in. Always around the origin. Fun stuff. And then let's talk about rotational symmetry really fast, and then we'll call it video for rotations. And then the next video we'll talk about compositions if you need review for that. All right. So rotational symmetry. Does this figure have rotational symmetry? Yes. Remember, rotational symmetry is a figure has to have 180 degrees or less. Technically, 360 would be rotational symmetry. Then everything would have rotational symmetry. Has to be 180 degrees or less. And then just to compute it, realize that how much points does this star have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 points. So literally you just have to match up the points. How much could I, let me see if I can do this again. I don't know how cool this will look. Maybe if I can make it transparent. Copy, paste image. Well, ooh, let me see, let me try something cool. All right, yeah. Notice how that's not rotational symmetry right there. It has to match up perfectly. All right, we want the points to match up. So not rotational symmetry. So how far am I rotating the points? Well, that's what we're going to compute right there, because this is it right here. Boop. But anyways, let me get that, delete that out of the way. All I have to go is bloop, right there. All right, and since there's 9 points, I'm going to take 360, which is a full spin, and divide it by 9, which gives me 40 degrees. All right, they gave you a lot of pictures for that. So that's a quick review on rotations.